Alright, imagine this. You are writing a function just for one small task, maybe multiply a number, or check a condition, or sort something. Now ask yourself, do you really need to write a full function for that? That's where lambda functions come in. These lambda functions are short, they are very fast, and simple one-line functions. So let's start with a very simple example. So usually a normal function looks like this. So you have a method add with the parameters and it returns the sum of the two numbers that you pass and it runs fine. But look at the lambda version of this. You can simplify this into a one line lambda. Using this, you simply say add equal to the lambda keyword and then the parameters colon and then a plus b. So it accepts two parameters, and then when you call this add, look how simple this method has been defined in just one single line. And when I run this program, you get the same 5, the sum of two numbers. But notice something, there is no def, there is no return, just one line of code. That's the core idea of lambda. So what is a lambda function? A lambda function is a small anonymous function written in one line. So it has no name unless you assign it. You can see I have assigned the name add, but you can simply call this directly in a program. But you can assign a name, but you don't need to unless you need it. So it doesn't have to have a name and it doesn't have any return keyword and only one expression. And the syntax is something when you can remember something like this. So lambda, the keyword, and the arguments and the expression. So you can see here, so I have the lambda here and the arguments a, b, and it can be any number of arguments and the expression. And that's it. Now let's slow down and understand this deeply. So here I have another lambda function that does the square of a number. You give a number and it is assigned to x. So we call this as square and we define the lambda here, a single line of code, and the output is when we say square of 5, it is going to do the 5 times 5, and that's what happened. So it took x and it does this expression evaluation and returned it automatically. So no return keyword needed here. So now here is an important mindset that you need to have, is that the lambda is not about replacing functions, it's about writing quick throwaway logic. So let's move on and see another example. Suppose you have the normal method and it does the times 2, doubles everything. So if you give 4, it prints 8 and so on. But the lambda way is just a single line of code, and you can even put this, we can replace this entire thing with a lambda. You can replace this entire code with this one print. So here it's an anonymous because I didn't assign any name. Just as we saw in the previous example, I didn't say square. What I did was I simply took this one line of code and then directly had this in the print. And then what about the value of x? So what I'm going to do is I'm going to put this in this and then in a bracket and then pass the parameter like this. So that's it. So it's going to print, pass this 4 to x and then it squares that. And look at how simple is this way, the lambda way. You can even run it instantly without naming it. So it's just a piece of code and you can use it just like any other code, just one line. And that's why people call it anonymous function. So this is actually a function, but it doesn't have a name. So that's why it is called anonymous function. So now let's go even deeper. Lambda can take multiple inputs. So here we saw only x But another example is here. Let's call this anonymous lambda. We assign it to this multiply, so we call that multiply with two parameters. So you can have a, b, c, so it can accept multiple parameters as well. So you can see the program just runs fine. And even conditions, you can even do some if logic, but it should all be in the single line of code. So you see the single line of code, and the lambda accepts one parameter here, 10, and then checks if the 10 is an even number. If so, it's going to return even, or else it's odd. So that's how simple this function is. So you can see 10 is even and 7 is odd. So lambda is very small but powerful. Now here comes the real use case. Lambda is mostly used with other functions, because sometimes a function needs another function. That sounds confusing, right? But watch this. In this example, we have a lambda and we pass the numbers, the list of numbers, and then we create a list out of it. We square each number in the list, and let's see. So you can see it takes each number from the list and then passes it to this lambda function, anonymous function, and the map, you can see, applied the lambda to every element. So that's how we got this. So now you can even go further and do the filter here, and that filter is this one. You can even do the filter logic. All you need to do is pass another lambda and then the numbers. So the list of numbers it checks each number is an even number, and then it prints only the even number. So we collect all the even number in a list, and you can see how simple it is. You don't need to write a method and call it. You can write this anonymous function on the fly, and it works here. So the lambda here decides which values to keep, and it keeps only the even values. So now comes the sorting. This is where lambda becomes very powerful. So here you can see the name value pair here, and when I run this code, you can see here it sorts the students by the mark, what is the score they got in their tests. So lambda tells Python how to sort. So you can see sorted method here, and it returns the in ascending order, and you can see simply the key is lambda, and the key is each one is we pass the numbers here, and then it is sorted. So simple as that. Now let's take a pause here. So this is how actually in real world people use lambda, not just for basic mathematics but for custom logic inside functions. So now let's go one more step deeper. You can combine lambda with list comprehension. So you can see here, when I run this program, you get 1, 4, 9, 16, and you can see each number is squared, and you can see for n in nums. So we use the list comprehension as well. So we are combining the lambda and the list comprehension. So this is amazing. But honestly, in real world code, you wouldn't always do this. But keep in mind, because readability matters. Now let's talk about what are the limitations of this lambda functions. Lambda has strict rules. The first thing is you can have only one expression in the lambda function, and there cannot be multiple lines. It can only have one line of code, and there cannot be, of course, no loops or statements, and you cannot make any assignments like x equal to 1 or y equal to 10. So no assignments, and because of that, lambda is of course not for complex logic. So when should you use it? Use lambda only when your logic is very small. For example, you need to square a number or simple expressions, and you should use lambda function only when you want to use it only once, and when you want to pass, when a pausing function, when you want to pass function as an argument, and when you want to do some quick transformations. And don't use lambda function when your logic is complex, because in that case it becomes too difficult to read, so readability suffers there. And don't use when you need debugging, because when you don't have multiple lines of code, you don't know where how debugging becomes difficult. Unlike in a regular method, you can put a breakpoint at a particular line and see what is happening inside the method, but this single line of code is not that useful for debugging. Now let's compare clearly one more time. So a normal method looks like this, but we can always shorten it using the lambda function, using the single line of code. So you can see the difference. So lambda is shorter but less readable for big logic. So use it for simple logic. And here I have a real world powerful pattern, and you can see here we have a set of data, and we can sort the data, and we have used the lambda here. And when I run the program, you can see they are sorted by age from smaller to higher numbers. Now imagine writing a full function just for this. Lambda here saves us time. So another real world case is custom calculation. Example I have here. So here when I print it, you can see here it prints the prices just like that, small, clean and fast. Now let's address a confusion many beginners have. Is lambda faster? Not really. It's not about performance, it's about simplicity of code and readability. So it makes us code simple and readable. Now let's log this in your mind. Lambda is a quick one-liner function for simple tasks. And here is the simplest way to remember. If your function fits in one line, lambda is a good option. If not, use a normal function. So let's end with one clean example combining everything what we saw today. And here I have this example, and you can see here how we call this lambda, and inside another filter, and we then use another lambda to store it. So you can see here how it is clean. And what happened, the filter actually removed all the values that are less than or equal to 5, and then arranged the remaining values, and then finally lambda controlled both. So now think about it. You just used two lambda functions inside one line. So all this is one line. So two lambda functions. So here and another one here. So that's the real power. So final takeaway is that lambda is small but not trivial. You can use it anywhere in real code. Especially you can use it in data processing, or in your QA or dev, or any automation, and when developing APIs, and when you do sorting and filtering like this. So remember, lambda is short, inline and one-time function. So use it smartly and don't use it everywhere. So if you like this video, give a thumbs up and like this video and share it, and subscribe to the channel for more tips and Python and other tutorials and other examples. So subscribe, and I will see you in the next video.